Harold here. Today I want to do something a little different. Um, I want to show you my solutions to the Maven Rail challenge. If you don't know what the Maven challenges are, Maven Analytics is a great site for data analysis, Power BI, tutorials, courses, guided projects, showcasing your portfolio. Every month or so, they have a new challenge to see what you can do with a set of data. Current month is the Maven Rail challenge. I'm going to not show you how I did my finished dashboard. I'll show it to you. I'm going to concentrate more on cleaning and the DAX measures I use to get my solutions. Hopefully, you can use these tips and do your own challenge. Maybe you'll win it. The Rail challenge, view the challenge. Maven Rail challenge. You're a BI developer for National Rail. Company provides services in Great Britain. You've been asked to create a dashboard that helps them identify popular routes, determine peak travel times, analyze revenue from different ticket types, and diagnose on-time performance and contributing factors. Data set contains mock sales from January to April 2024, etc. And you can just download it here. So UK train rides 1 zip. Let me go to my downloads. There's UK train rides. I'm going to drag it into, excuse me, I'm going to drag it into a folder I've created here, Power BI Rail Challenge. Okay, open that thing up. You really just need the Railway CSV file. I'm going to drop it right on Railway Challenge. Rail Challenge also. Okay, now we're going to go to Power BI, start a new report. I've got an untitled Power BI desktop. Let's just save it real quick. Okay, I got a Rail Challenge Power BI blank desktop. Let's get some data. I think it's a CSV file. Go to our railway, open that. We're gonna always transform. I don't care how many columns it is. I always transform just to even just to check data types. So now we're in Power Query. ABC date, time, ABC text, ABC. Okay, these are all looking good. Let's change price to fixed decimal number. And what else? Date, time, text. Okay, not many changes there. Just changed price to a fixed decimal number. There is a departure and arrival time and actual arrival time. In one of our objectives was to analyze delays. So we're going to need a time of actual arrival time minus arrival time. So in order to do any calculations on our delay time, this is the easiest place to do it. So we'll add a column, go up to our time, and just do a subtract. So that gives us delay time. We'll change this column name. Delay. And it's a time duration. That's good. Oh, I spelled delay wrong. Okay, got our delay column. You look at reason for delay, there's a lot of blanks, but there's also duplicates, 2 signal failures, 1 spelled wrong. Staff shortage and staffing are the same thing, and weather conditions are the same. So the easiest way I think to do this is to place values. So we will replace signal failure with signal failure. Okay. So that's gone. We'll replace staff shortage with staffing. Okay. And let's replace weather conditions. Let's just replace conditions with blank. So we'll replace space conditions with blank. Nothing. Okay. So now all we have is blank, signal failure, staffing, technical issue, traffic, and weather. Um, these blanks won't be very helpful. So instead of blank, we will replace blank with NA. Not applicable because these were on time or canceled. All right. So now we have NA, signal failure, staffing, technical issue, traffic, and weather. Okay. So that's good. So let's go ahead and go home. Close and apply. Now we've got our railway table, all our columns. Start to do some measures. We do need one more table, and that is a date table. Every time you have dates, create a separate date table and join it. It's a must when you're doing Power BI. The way I find easiest to create a table is in this date table needs to be all the dates in 2024, even though we're only at January through April. When you do a Power BI date table, you have to include all the dates in the year, even though they're not in your other table. So Power BI date table, ChatGPT for calendar year 2024. Include, well, we'll see what it comes up with. So it writes the date table, add columns, calendar date formula for you, picks out a bunch of stuff you might need. Can we get year, month name, etc., etc.? I'm interested in day of week, day of week name. I want to do my analysis by weekday, by route. So I will copy this code. We will go back to Rail Challenge, table view, new table, paste. I like to call mine calendar. And now I have a date table. If I need something else, just ask ChatGPT to add it on and it will. It even tells me if it's a weekend or not. That might be helpful. So commit that. Now I have a calendar table. Go to model view. And let's connect date to date of journey. And just in case we need it, let's make this one inactive. And connect date to purchase. And we don't want that one to be the act. You can only have one active relationship at a time. So we'll inactivate the purchase one. We're more interested in analyzing by journey, so we'll reactivate that one. Okay. Now, we'll go back to report view and we'll get started on some DAX. Okay, before I get to any of the advanced measures, I'm going to do some basic key measures. I like to do a measure table. So real quick, enter data from your home tab, key measures. That's all you need. You can't call it measures. That's reserved for the system. Load. You have a one column table named key measures. You can put your measures in there. Once you put another measure in there, you can delete column one. You just have to have a column in a table. So that's a placeholder for now. New measure. These are just the basic ones. I'm going to do 3 of them just so we can do the other things. So revenue, in this case, line for line, every ticket has a price. So we just have to sum the price. Let me blow my formula bar up here for you guys. Scroll, scroll. Revenue equals just some price, railway price. That's it. Put some cards out here so we can play with some of this stuff. And so our total revenue is 7141.92K. Couple housekeeping details. I always do this, so put this in the right table. And we are in remove column 1. Link for model. Yes, I'm sure. And we are in Great Britain, so let's change the dollar sign to pounds, English United Kingdom. All right. Couple more key measures on the key measure table. New measure. We need to know how many tickets we sold. because the table is it's a list of individual tickets. All we have to do is count rows. What in the railway table? Put another card up. Okay, 32,000 tickets were sold, approximately, depending on how this is rounding. And one more, I'm analyzing lateness. I want to know the total delays. So one more new measure. Total delays equals, and here we can do another count rows with a calculate, because we're going to put a filter on it. So we're going to calculate. Our expression is count rows. Table is railway. And the filter is table is railway, and the filter is status, railway journey status equals delayed. We need to close our count rows and close our calculate. Nope, we already did that. Close our calculate. So total delays. Get one more card up here. All right, out of 32,000 tickets sold, we had 2,292 delays. And there's our revenue. So there's some basic measures. Let's put those down at the bottom for now. Now, for my advanced measures, uh, we're going to do analysis of route popularity. So to do that, we need to get all the routes. To do that, I'm going to go to the railway table and table view. Add a new column. And call it column route. And all I want to do here is concatenate departure and arrival with a dash in the middle. So railway, departure station. We'll just use the ampersand. Seen any of my videos on concatenate? You're very familiar with this. If not, please go watch them. And arrival station. Arrival destination. Excuse me. Nope, that doesn't need any parentheses. That's just this and this and this. Railway departure station and hyphen railway arrival destination. Actually, let's put a couple spaces in here too. Okay, commit. So these are all our routes. Distinct routes. Okay. So now you know how to get the routes. To judge the popularity, let's go back to visual report view. I did a measure to rank them by tickets sold. So let's do that one. Now we're getting a little more advanced. Key measures. New measure. Uh, got my tickets sold. So I'll say ticket sold rank equals. It's not complicated. It gets a little long. So follow along. Hopefully you get it. Try to go slow. Ticket sold rank equals if I'm doing a conditional check before I even rank them. So I'm going to say if it's in scope, because ranking has a problem, it will put a grand total on there of 1, ranked 1. So we're getting rid of that. So if it's in the scope of route, we want to rank it. If it So we do a rank X. Keep saying I'm going to do a video on rank X. I promise I will. Um, we need to say all selected. Then we need to say our table name, expression, railway route. Rank X all where railway route. So close are all. We're all selected. It should be an all. Rank X all railway route. So we're moving a table of all railway routes, comma, by. So what are we ranking it by? Tickets sold. The next argument is value. We don't use that one, so we put a comma and then another comma. The next argument is ranking. When you do sales, you usually want to rank from highest to lowest, so that's descending. And the next is how to handle ties. Dense is if there's a tie for second, the person who comes in after those guys is third. Skip is if there's a tie for second, the person that comes in after those two guys is fourth. I like to use dense. When we close our rank X, and then we say, if it's not in scope, we don't want to see anything, so put blank. And let me fix that. And then we need to close our if function. Ticket sold rank. If it's in scope, a railway we're out. We want you to show the rank, which takes care of everything, the ranking. If it's not in scope, take that ugly total off, put blank. So let's get a table out here. We'll put the route on there. And we will put our ticket sold rank measure on there. We'll sort it. Ascending. And the most popular route by ticket sold is Manchester, Piccadilly, so on and so forth. You see a lot you could do with that in the report. Okay. Now, once I've done this, now let me put a couple of splicers up here. We'll put a route slicer. It's going to get pretty big and long. Probably preferable to do a searching full slicer if you do this one. And I'm going to put a day of week name slicer out here. And you need to go to uh, day of week name, sort by column, day of week, so that sorts right. So Monday, Tuesday, Wednesday, and I don't know why they're blanks. And I'm going to filter out any blanks. Just pick blank out of my slicer. I've got a route slicer, a weekday name slicer. I'd like to dynamically display the chosen route and weekday in a card up here. Put a giant card up here. And if you've seen any of my multi-slicer dynamic label videos, you'll know what I'm doing. But let me do it again for this one. So new measure. I'm going to copy this one in and just explain it because it's rather long. And let me commit it and make sure it's okay. I'm going to take it to the calendar table and put it in the key measures table. So I wanted to select a route day in a big label. I want to click on those slicers or anything, and I want it to say Tuesday, or Manchester and Liverpool, Tuesday, or Manchester and Paddington, the Liverpool and whatever, Tuesday and Wednesday. So I want multi-slicer, multi-select on a label. And if nothing's selected, they should say all routes on all days. So first I did a var selected route. Here I used an is filtered, which allows me to give the alternate answer. So if it's filtered, if railway route is filtered, I want you to concatenate the distinct values in railway route, concatenate X, the distinct values in railway route against railway route, it's hard to say. Unichar 10 is a space, the universal character code for enter, so it'll move down a line. And all selected railway removes all the filters except the selected ones on railway. And the last part there, if none are selected, return. And that's some old notes. Say routes. None are selected, return all route. So if railway route is filtered in any way, concatenate anything chosen, any routes. So route 1, enter route 2. Next, I have another var for selected day. It's the same thing. We're just using calendar day of week name, checking the values against the day of week name, concatenating, enter down, remove all selected filters from the calendar table, and if not filtered, return all days. Then my return is just a statement in quotes, weekday route analysis, :space, ampersand, enter, so it should go down, ampersand, selected day, should print the day or days I've selected, enter down, it should display the selected route I've chosen. So let's commit this measure. And I'm going to put that selected route and day in this visual card box. And right now I have something checked. Seems to have worked. Okay. Weekday route analysis. Thursday, all route. Weekday route analysis, Thursday, Birmingham, New Street. I may need to do some formatting on my unichars, but weekday route analysis, Wednesday, Thursday, Birmingham, New Street. So on and so forth. I think maybe it's just the size of the box, actually. Yeah, okay. So that's better. So chosen route and day. So anybody sitting down and look at my dashboard will know exactly what route or routes and day or days they're looking at. And if I take them all off, weekday route analysis, and now weekday route analysis, all days, all route. Perfect. Okay. Now we wanted to do a peak traffic analysis. That one's kind of an easy one. Go to table view, railway table. You do a new column. And we use a rounding function on the time. I'm just going to use departure time right now. So I call this departure floor. Departure floor equals running function called floor. Take it down to the nearest multiple of your specification. So floor, and I just want the floor of what number? Departure time. You can do this with time, integers, etc., etc. I want the floor of departure time, and the significance I want is a half-hour significance. So I put 0:30, 30 minutes. Gotta be in quotes. We'll close that. This should create a new column. And it is in decimal number, so we'll convert it to time. And the 6:45 train 6:30. Let's find a different value here. 11 o'clock a.m. train, 11 a.m. 8:30, 8:30. So that seems to have put my time, departure times into half-hour buckets. So we can now visualize peak traffic analysis. So let's go back to port view. We'll add a clustered column chart. Open a departure floor. Where to go? And our x-axis. And tickets sold for all our journeys in our y-axis. Okay, that's really cool. I now have a graph of the most popular departure times. As you can see, it looks like in the morning, in the afternoon, in the evening and afternoon. So that jives with what you would think. Now you can do a lot more with that. Do arrival time, floor, just differences, time differences, etc., etc. Uh, so the next thing they wanted was to analyze delays. So we'll do a new measure. Because I did that column in Power Query where I've got the delay time, I can now apply LCI and duration to aggregate and iterate time values. And I never write this one. It's just in my toolbox. I just change the column table variables. I'll put it out here now and explain it to you. I'm going to do average delay. So average delay, what Chelsea did was she created a var to take the total seconds of any time value. So hours times 3600, minutes times 60 plus seconds. That'll give you the total second of any time value. Total number of seconds in any time value. Then she applies the average. So all this is calculating, turning it back. So she takes the total seconds and divided by 24. That gives you the number of days. That's the inch. 24 times 3600. Take the remainder, the modulo, and divides that and gets the number of hours. What's left, the number of seconds left, she divides into minutes. And then after that, the number of seconds left, well, the remainder of that is seconds. And she reformats it. So you can add time together, average time values, get to max time, min time. In this case, average and max might be pretty important when you're analyzing late times. This one's the average. Let me show you how that works. So I just need a card for this. Average delay, 3 minutes and 15 seconds. Now you could do max late time for each line. Uh, let's put the line slicer out here, the route slicer out here. So this is pretty powerful stuff, I think. Uh, Average delay, there were none at Birmingham New Street. It did pretty good. Let's find with a delay. Okay, here's one. Manchester Piccadilly. Average delay was 5 minutes and 9 seconds. And the most people left. It's in a very popular station. Most people departed at 2 a.m. and 9 a.m. and not a very popular station. Anyway, let's take these off. So I like this. See a lot you can do with this. In the railway challenge, let me real quick show you what I did. So Sunday, all route, searchable route box. Sunday, Birmingham, New Street, Coventry. Take that back off. Reason for delay, so you can analyze signal failures on Sunday. Uh, Ticket class analysis, just use the slicer here. Peak travel times, you saw me do that graph. Here's your top 5 routes. I got ranks for tickets sold and revenue. I did want to analyze the revenue. Got KPI cards for average delay, the maximum delay for that line or day, the ticket revenue, and the tickets sold. I think it's a pretty good snapshot for route analysis, and that's the one I submitted. Hope you try to submit one yourself. Hope you have fun doing it. Hope my measures were helpful. If you like this, please like it, subscribe, and I'll see you next time. Thanks, everybody.